So gentlemen, could you tell me who you are and your roles?
I'm Dr. Lauren Picot, and I'm CEO of Bristol Nanodynamics.
And I'm Dr. Oliver Payton, and I'm CTO of Bristol Nanodynamics. We've developed Vector. We launched it coming on to about a year ago now. It's about our 6th generation of microscope.
It's an extremely versatile tool that will happily sit in an academic research lab or an industry laboratory environment.
All the previous generations have been very much, this one's tailored towards biology, this one's tailored towards metallurgy, this one's tailored towards the nuclear industry with a big lead shield. Vector has been designed to try and meet the needs of as many different industries as possible.
We make use of a very unique piece of physics that no one else has touched upon, no one else is using in their instrumentation. And it means that our instrument is not only faster than the competition, it causes less damage to the sample and to this very sharp imaging tip. So our consumables will last 10 times, 100 times longer. At the same time, it becomes a really robust, easy to use tool.
But talk to me about how groundbreaking it is.
Incumbent technology, traditional scanning probe microscopy, is very slow, and it can take anything from about a minute to an hour to collect one frame. In our situation, it takes 2 minutes to load a sample, start imaging. We can assess millimeter-sized areas in minutes, carrying out literally a year's worth of atomic force microscopy in a day.
Vector works across 7 orders of magnitude. You can see your sample at the centimeter all the way down to the nanometer, okay? And your data is carefully correlated by us all the way across those length scales.
The only other tool that you could have kind of 7 orders of magnitude from nanoscale to centimeter, you're talking diamond light source, huge national facility, pieces of equipment that the size of a small village, rather than a tabletop instrument, which is what we developed.
And we've designed it to play well with other tools. It uses industry standard sample stubs, which means that you can take your sample as part of a big workflow that you may have. You may be imaging it with a scanning electron microscope, you may be doing elemental analysis, and now you also get the benefits of our data feeds as well. It's a very complementary set of measurements of the material properties of the sample surface. And it plays well with all of the elemental and electronic analysis that you might do with other tools.
It sounds like an industry game changer.
This is a game-changing, really disruptive technology that supersedes all scanning probe microscopes really to date. We've really designed the system to be quite an open architecture. So if someone wants to design an experiment to look for single molecules, they can work with us and we'll design experimental protocols for that. If they want to look at all sorts of different metallurgy features, then we've got a huge recipe book now of how to prepare your samples for looking at different structures in metals. Working with customers and potential customers and people who use national facilities which use our products, and working really closely with them, it just grows the arsenal of capabilities that the system has, really. The system was quite heavily tailored towards the use cases of materials science, particularly metallurgy, but actually there's a whole range of capabilities and industries that our technology can benefit. Over the years, we've imaged samples from eyeballs of fish to single strands of DNA on surfaces, to bits of nuclear reactor. Our customers have used the systems for such a huge range of samples.
We really succeed where people can see it. We are very happy to take this on the road. We will take the instrument to you. You are very welcome to come to us in Bristol. We will always offer an initial sample assessment. We will show you on your sample that this tool works. This technology is something we really believe in, and we have a wealth of understanding from our own academic careers and our industrial collaborations with companies such as Rolls-Royce, Afton Chemical, EDF Energy. We know that this is a tool that can work on an enormous range of samples, enormous range of situations, and we genuinely believe it can help solve any kind of measurement challenge where you need nanoscale information, maybe very quickly or maybe across large areas.
Dr. Lauren, Dr. Ollie, thank you very much.